Hi everyone, thanks for coming to Google Open Source. I'm Cici Huang, and I'm currently working at Google as a software engineer. Today, the topic is admission webhooks. Put the power in your hands. First, let's take a look at today's agenda. We are going to talk about what are admission webhooks, why people need admission webhooks, and how to configure a custom admission webhook, some best practices when you think about your use case and configurations, and then the way to monitor your admission webhooks behavior. And at last, we will have a short demo. So let's first take a look at what are admission webhooks. Here is an overview of the API request lifecycle. To understand the admission webhooks, first, we need to understand what is the admission procedure in Kubernetes. An admission controller is a piece of code that intercepts requests to the Kubernetes API server prior to persistence of the object, but after the request is authenticated and authorized. Kubernetes ships with a lot of admission controllers, and there are 17 of them are enabled by default in v1.19. A lot of things which we assume are native to Kubernetes are actually done by those admission controllers. And they can be turned on with the Kubernetes API server flag enable-admission plugins. Let's take a look at some admission controllers as examples which are shipped with Kubernetes. Here is a namespace lifecycle controller. And when the request comes in, try to create a deployment with the name myDeploy in the namespace test. And if the test namespace currently in terminating status, there's no point to create a new deployment. So the namespace lifecycle controller will simply just fill the request and return to the user. Another example will be the always pull images controller. We will check the image pull policy and update it to be always if it was not. As we can see here, the admission controllers can be categorized into two types, mutating admission controllers and validating admission controllers. And some may be both. Mutating controllers may modify the objects they admit. Validating controllers may not. The admission controller process proceeds in two phases. In the first phase, mutating admission controllers are run, and in the second phase, validating admission controllers are run. If any of the controllers in either phase reject the request, the entire request is rejected immediately and an error is returned to the end user. Among those admission controllers shipped with Kubernetes, two take a special role because of their nearly limitless flexibility: mutating admission webhooks and validating admission webhooks. They do not implement any policy decision logic themselves. Instead, the respective action is obtained from a REST endpoint of a service running inside the cluster. This approach decouples the admission controller logic from the Kubernetes API server, thus allowing users to implement customer logic to be executed whenever resources are created, updated, or deleted in a Kubernetes cluster. The difference between the two kinds of admission controller webhooks is pretty much self-explanatory. Mutating admission webhooks may mutate the objects, while validating admission webhooks may not. And mutating admission webhooks are called in serial, while validating admission webhooks are called in parallel. So why do we need admission webhooks? The admission webhooks can help in certain areas. So they can help with increasing security by mandating a reasonable security baseline across the entire namespace or cluster. For example, we can only allow pulling image from 30 registry inside your corporation, and we can disallow containers from running as root. And secondly, they can help to enforce the adherence to certain practices, such as having good labels, annotations, resource limits, or other settings. Like we can enforce some label validation or add annotations to objects, like add a cost center. And third, they can help with configuration management. For example, we can add resources limits or validating resources limits. And also, we can ensure image references used in production deployments are not using the latest tags. Then, how can we configure our admission webhooks? Before we take a deep look at the configuration fields, there are some prerequisites we'd better keep in mind while using the admission webhooks. First, we always have to check the Kubernetes cluster versions. It has to be at least v1.16 for using admission registration.kubernetes.io/v1, and it should be at least v1.9 to use the admission registration.kubernetes.io/v1 beta 1. And we also have to ensure that mutating admission webhook and validating admission webhook admission controllers are enabled by the flag we talked earlier. And also, we should ensure that the API is enabled. Here is an example of a validating webhook configuration. I will not go through all the fields in the detail. Basically, it's a validating webhook configuration. It only contains one webhook with the name pod-policy.example.com, with the rule triggered on every namespace pod creation request. The client config tells API server how to contact the webhook. And this webhook does not have any side effects, and it has 5 seconds timeout for the API server to call the webhook. There are some other optional fields you can set, which does not show here. We will talk about them in more details in the following slides. And there are always some best practices recommended in terms of thinking about your use case or think about how to configure your own webhook. The first one is idempotency. What is idempotency? Idempotency is like it after applied multiple times, the status, the result, and the side effects should be exactly the same as being applied once. So here is an example of idempotent mutating admission webhooks. Always pull images. So whenever, no matter how many times it's been called, it will always check the image pull policy field and update it to be always if it was not. Another example shows a non-idempotent mutating admission webhooks, which is try to inject the sidecar with the timestamp in the name. So when it's being called at the first time, it will append a sidecar container in your container list with the current timestamp in the name. But when it's being called the second time, it will append another sidecar container into your containers list with the timestamp, which might not be something the users wanted. So why we want the mutating webhook to be idempotent? Because mutating webhook may be called twice by the API server. A single ordering of mutating admission plugins just does not work for all cases, because some other admission controllers may mutate the object, and the decision may be different depending on the order. Let's take a look at an example. Here in the example, we try to inject the sidecar, and when this controller being called, a sidecar container being appended into the pod. And then always pull images being called. So we will go ahead and check the image pull policy to all the containers and updated them to be always. But what if the order is different? If we first call the always pull images, which will update our image pull policy to be always, and then the inject sidecar being called. So it will try to append a sidecar with the name sidecar in the containers list, but the image pull policy is not set to be always, which against our expectation. So we try to apply the best effort reinvocation mechanism by allowing to set the reinvocation policy field to be if needed. So in the previous case, the inject sidecar being called, and they ingested a sidecar container into the container list. And then the always pull images is allowed to be called twice and updated the image pull policy to be always, which made the expectation. And the second best practice is intercepting all versions of an object. We all know that Kubernetes supports multiple API versions. For example, Kube API server allows creating, updating deployments while extension/v1 beta 1, apps/v1 beta 1, apps/v1 beta 2, and apps/v1 APIs. If a webhook is configured to only intercept deployments requests in apps/v1, it will miss requests in the other versions. It is recommended that admission webhooks should always intercept all versions of an object by setting the match policy field to be equivalent. It is also recommended that admission webhooks should prefer registering for stable versions of resources. And failure to intercept all versions of an object can result in admission policies not being enforced for requests in 30 versions. The next best practice is availability. The time calling webhook builds up time calculating the entire API request. So it's always recommended that admission webhooks should evaluate as quickly as possible, and it's encouraged to use a small timeout for webhooks. In this example, the validating admission webhook sets a 2 seconds timeout. If the webhook is being slow and doesn't respond in 2 seconds, the API server will either reject the request or ignore the failure based on the failure policy set. The next best practice is guaranteeing the final state of the object is seen. If you use a mutating webhook to enforce security policy, make sure to use a validating webhook to ensure that, because another webhook may be invoked after your admission webhook being called. And then the next best practice is avoiding deadlocks in self-hosted webhooks. So a webhook running inside the cluster might cause deadlocks for its own deployment if it is configured to intercept resources required to start its own pores. Let's take an example. A mutating admission webhook is configured to admit create port request only if a certain label is set in the port. In this case, we require the environment label to be set to production. The webhook server runs in a deployment which doesn't set the environment label to be production. And when a node that runs the webhook server pores become unhealthy, the webhook deployment will try to reschedule the pores to another node. However, the request will get rejected by the existing webhook server since the environment label is not set correctly, and the migration cannot happen. So, we recommended to exclude the namespace where your webhook is running by setting the namespace selector fields. And another best practice is side effects. Always try to avoid side effects if possible. And if it cannot be avoided, don't trigger the side effect in dry run by set the side effects field to be none on dry run. And the last best practice is avoiding operating on the kubesystem namespace. The kubesystem namespace contains objects created by the Kubernetes system, like service accounts for control plane components, ports like kubedns. Accidentally mutating or rejecting requests in the kubesystem namespace may cause the control plane components to stop functioning or introduce unknown behavior. If your admission webhooks don't intend to modify the behavior of the Kubernetes control plane, exclude the kubesystem namespace from being intercepted using a namespace selector field. Here is an example. Only match the requests in a namespace which the rule level value is not equal to 0 or 1. It also helps with efficiency, since we mentioned earlier that every webhook invocation latency builds up the entire API request latency. By excluding the kubesystem namespace, the webhook invocation is scoped to only what it needed. Next, let's talk about the ways to monitor admission webhook behavior. There are some questions. The answers to certain questions can definitely help us to monitor the admission webhook behavior, like which mutating webhook mutated the object in API request, What change did the mutating webhook apply to the object? Or which objects are frequently rejecting API requests? And what's the reason for rejection? The API server provides two main ways to monitor. The first is through auditing. Kube API server performs auditing on each mutating webhook invocation. Each invocation generates an auditing annotation capturing if the request object is mutated by the invocation, and optionally generates an annotation capturing the applied patch from the webhook admission response. For the audit level metadata or higher, an annotation with the key mutation.webhook.admission.kubernetes.io/round with round index with order index gets logged with JSON payload indicating a webhook gets invoked for given request and whether it mutates the object or not. The example on the left shows an annotation gets recorded for webhook being invoked in the first round, and the webhook is ordered the first in the mutating webhook chain, and mutated the request object during the invocation. For the audit level request or higher, an annotation with key patch.webhook.admission.kubernetes.io/round with round index with order index gets logged with JSON payload indicating a webhook gets invoked for given request and what patch gets applied to the request object. If we take a look at the right example, the annotation gets recorded for webhook being reinvoked. The webhook is ordered the first in the mutating webhook chain and responded with a JSON patch which got applied to the request object. And we can also monitoring the webhook by the metrics endpoint. There are two metrics which highly related with the admission webhooks. The first is the API server admission webhook admission duration seconds, which is a histogram metrics, tells you how long the webhook admission takes. And the second is the API server admission webhook rejection count, which is a counter matrix grouped by name, operation type, error type, rejection code. And below are the examples of how the metrics log look like. And now let's take a look at a short demo. So the demo use case is fairly simple. We want to have a validating admission webhook which could ensure ports run as a non-root user. I have four examples of ports try to be created. The first one without the run as non-root being set at all. And the second one, we set the run as non-root to be false. The third one, we set the run as non-root to be true, but we are giving an admin user. The third one with the run as non-root to be true and with a given user as 1, 2, 3. So the Kubernetes API should reject the first 3 requests and only allow the last one to be passed. And here is our validating webhook configuration, which we have one webhook called kubernetes-validation-webhook.demo.com. And for all the ports creation request happening in the namespace, which has the webhook label to be enabled. And here is the error. Here is the API behavior returned when we try to create the ports. And I will not do a live demo in this talk, but I have all the demo code uploaded into the GitHub. If anyone is interested, please feel free to take a look. That's the end of the talk. Thank you.